Hello, everybody, and welcome to the presentation it's a joint presentation by Parasoft and Lattix. And today we're going to be talking about tools and methodologies to test compliance with 61508. My name is Andrey Madan. I'm this guy right there on the left. And my co-presenter is Neil. Hi, Neil.
Hi, everyone. Hi, Andrey.
All right. Today, your presentation is recorded, and we do appreciate the opportunity to present today. This is the agenda that we put together. The important thing about how we're going to run this presentation today is we are going to probably rush through some of the slides, having in mind that you will have them recorded and you can pause and look at the slides a little bit with more detail. Okay. A little bit of Parasoft. I represent Parasoft. We are part of a Zephyr project. We're silver sponsors. We also have a spot on MISRA committee. So we've been doing development testing software testing products for about more than 30 years. And that's what's important. And we're global. We have a global presence. Neil, do we want to say some things about Lattix?
Yeah, thanks, Andrey. At Lattix, we're Boston-based. We have a worldwide network of distributors and partners, enabling us to provide architectural-focused consulting and products worldwide. We particularly help with compliance and functional safety, and compliance to the architectural requirements of functional safety standards such as 61508, which we're talking about today, 62304 for FDA medical, ISO 26262 for automotive, and avionics DR178C. We support a wide variety of languages from C and C++ to C# through to Python. We can also visualize dependencies from models and languages such as Ada, Fortran, and Oracle. And the aim is to see dependencies to help improve the structure, refactor code, define an architecture, communicate that architecture, and also automate and improve DevOps automation through testing and building the software more efficiently.
So yeah, Parasoft and Lattix, just full disclosure, right? Parasoft and Lattix, we're vendors, we're partners. We'll be focusing today on the high-level approaches of how people generally address 61508 compliance. But some of that will actually touch on the product features as well. So with that, Neil.
Yeah, thanks, Andrey. Again, this is the grandfather of the functional safety world, IEC61508, from which most of the other functional safety standards are derived. And you can see how they interact with each other, what functional areas they cover from industry, automotive, medical, energy, transportation, and buildings. Many of these standards have a lot in common in terms of what's required for software testing, for validation, traceability, verification. The language is very similar. And so we're going to take a special look at 61508, from which these other standards are derived, and see what that standard has to say about these important domains in the safety world.
Yeah, the general guiding principles, they're all shared. Some of the standards like 26262, for example, for automotive, has a little bit more details, right? So depending on which flavor of standard we're talking about, that has more flavor, more details or less details. But in general, they're all sharing the same patterns. And that's what we're going to talk about today, are kind of the patterns that do exist across all of the standards, okay? So the first pattern is architectural design principles. It exists in all of those standards, and it has to do with architecture, where Lattix is actually our partner expert in that area.
Yeah, and I can show a couple of things here, Andrey. Let me just share my screen.
Yeah, why don't I stop sharing and you share? Yeah.
So architecture is often communicated through diagrams, and this is a great example of somebody trying to communicate an intended architecture. This is an open source piece of software called ISO-glib, and it's got different layers. Somebody's taken the time to define what those layers are called, and it relates to the functionality of those layers and the intended provider subsystems. For example, drivers providing to hardware abstraction layer, providing to driver extension, provided to communication at the top. And someone's tried to express some design intent here as well. These gray modules here, for example, should be independent from each other. These colored modules are core modules, they're mandatory parts of the system. So this is a kind of plug and play architecture. Some modules could be there in some configurations, some may not be. And we're going to see how this looks in the code. often people define a great architecture at the beginning of a project, but then over time, developers like me come along and they make changes and they introduce inadvertently some maybe unintended or bad dependencies. For example, from hardware or utils up to the top of communication. And that makes the architecture worse. We have a divergence or a worsening of the architecture, an erosion of the architecture. And Lattix exists as a product to help to keep the architecture on track, identify those places where the architecture is going wrong, and improve the structure of the architecture. But I thought, Andrey, it'd be pretty fun if we loaded up Zephyr and looked at the dependencies of Zephyr and see how different parts of the system interacts with each other. And so this is a DSM, a dependency structure matrix of the Zephyr project. And the way we read a DSM, we go down the column to see what something is using. So tests are using architecture and SOC and boards. And you can see the strength of those dependencies. So you can see where most of the tests are located actually immediately, which is interesting. You see some parts are not so covered by tests, some parts are more heavily covered. And we read across the row to see what components used by. So subsys here is used by samples, is used by drivers, and you can see the dependency strength. And really, after partitioning, which is a technique, architectural technique, most relationships in a well-designed system should be below the diagonal. You'd expect to see that below the diagonal. And lib, you wouldn't expect to see anything above the diagonal, because that means a library is using or calling something above. Libraries are intended to be used rather than use other things. So you can immediately kind of identify some areas where maybe the architecture could be improved, or maybe there's some surprises. Some couplings in both directions that you may then want to sort out.
So common question that we get at this point of a demo, Neil, is that how did you obtain those numbers? Did you read the diagrams that you just displayed at the previous page, right? Or what kind of data is an input to this analysis?
Yeah, so it's a great question. In this case, we imported the data from the Parasoft C++ test, which has a very advanced parser from the Edison Design Group, edg.com, and that has every possible part of the C++ language, right. the abstract syntax tree exactly, defines, includes global data, and we visualize all of those. So pretty much the whole of the C++ code is visible in terms of dependencies between these different objects. And you can see, the numbers are the kinds of relationships that you see in the C++. They could be includes, they could be types, reading of variables, and now you can get different views of the architecture. I could just limit to global data, for example, and then look at control coupling, data coupling, see where things are coupled from a safety perspective. I would see which parts of my system have global data that connects each parts of the system, which is an interesting view. I can also, from a testing and organization perspective, maybe in Zephyr, there's an intention that some of the drivers would be independent. And I looked at the drivers, which are kind of quite a big part of this system, 4% of the system. And you can see lots of decoupling. There's lots of independence here between the drivers. So what I could do as a design intent, I could say that all these drivers should be, independent of each other. I can create subsystem rules. Yeah, it's kind of a nice
It's
rule.
almost like a static analysis, like you're getting to static analysis, right, type of things.
Yeah, exactly. And then if I, as a developer, create a bad dependency between reset and PS2, for example, then I want to basically create a bad, say that this is a bad rule, a bad dependency. So I could create that independent subsystem between these, and in CI I can enforce it as well.
So I'm curious, how does it help? How does this view help you in your experience to make a structured argument about 61508 compliance?
Yeah, so if we went back to your slide there, Andrey,
right? Yeah, let's go there.
Where you dropped the text of the standard
compliance.
Exactly. So I think I need to stop sharing first.
Yeah, no, I can take it. Do you see the slides now?
I do. Yeah.
Perfect.
Yeah. You can see that the language of the standard talks about appropriate design, appropriate hierarchy, which is obviously enforced in those rules. Communicating design intent is an essential part of the DSM. So you're saying it's an expression, I want this component to talk to this one and vice versa, and this component not to use this component. So usage rules, they map very well to parts, table F2, 2.1 through to 2.7, those requirements.
Well-known tables.
Yes, exactly. Well-known tables, and certification authorities like the TÜV in Germany, they want to see evidence that you've complied with the standard. Things like 2.3, freedom from intrinsic design faults. You can often show, or in ISO 26262, that's called freedom from interference. You can show in the architecture that two systems, it's not possible to communicate between those. There's no dependencies between those parts of the systems. You can label them with different ASILs or different SILs in the 61508 language, and you can prove that parts of the system are indeed decoupled.
Exactly. All right, so that was the architectural piece of it. As I always say, that you need to be, before you need to be able to verify properties of the architecture, you need to describe it in some way that is verifiable. So that's what Lattix and Lattix Architects does. All right, so now static code analysis to have comply with certain tables in certain areas of the standard. The 61508 doesn't get into the details exactly which rule sets you'd like to enable or disable, exactly which coding standards needed to be set to comply. However, this is just the beginning of the table there from the standard. It gives you different like a general guiding principles, and all of those guiding principles are captured in well-known coding standards such as MISRC 2012, which is right now the most up-to-date standard for C language. There's a also update to that, MISRC 2012, coming in June, and it will be released in Embedded World, where Lattix and us are going to be presenting. Plug, little shameless plug. So Embedded World in Germany is coming in the end of June. All right, so for C++, we recommend AutoZAR C++ 14 standard, which is the most up-to-date standard for C++. There are other standards which are good to look into. Most of them are related around security, and there's some overlap. So for example, there's a standard called CertC and CertC++. They do have some overlap with safety standards such as MISRA and AutoZAR, but you can also have your own analysis done and combining the two, creating yourself a standard for your organization, which is, by the way, what Zephyr did. The Zephyr is using Parasoft, and Zephyr project looked at all of the Parasoft rules and mapped them to coding guidelines, Zephyr coding guidelines. I think it's on this slide here, where there's a link to Zephyr coding guidelines. For those of you who haven't seen them, you can just look at that link or browse the Zephyr documentation page. And that's a snapshot of today, static analysis violations of Zephyr with respect to the coding guidelines. So that's if you drill into, let's say, subsystems or some of the other architectural parts that Neil was showing, you can see more details about every violation here, and then look at the what the problems are, look at documentation, read it, understand how to repair it and whatnot. Anyway, so that's point here is that Parasoft has been used in Zephyr, and there's a lot of desire for Parasoft to continue that sponsorship of the product of the project by providing our tools and expertise here. Okie dokie. So now we're back to, so that's about static analysis, right? You pick your rules, you map it, and then you're just kind of a couple of things that you can see here under compliance specs, right? You can choose from some of the rule sets. That's what we did with Zephyr, right? And then you can look at the rule packs and choose for yourself, like, which rules you want to be compliant with, which rules you don't want to be compliant. So the idea there is that with compliance of 61508, it's a generic standard, and you want to have flexibility to pick and choose your own rules and mapping that you believe are the right representation of mapping to that standard, and you want to defend it against with the TV certification authorities. So we can of course help there along with Lattix to do that exercise. Okay. So now we're back to. All right, so that we talked about static analysis. Zephyr certainly uses that, and that's a TV certified tool. So we'll be talking about the importance of using the tool that has been certified in your development life cycle, because at the end of it, so that's a unit module testing, but I just want to say some things about TV certification. It really helps you to structure your argument with authorities. When they ask you questions, is the tool been validated or qualified or tested to the extent where you know that it's actually addressing those coding standards, requirements, and recommendations. So that's where a TV certified tool, using TV certified tool really helps.
Yeah,
all right.
And you can get them excited as well, because when we worked with them to automate the documentation generation from Parasoft and Lattix together, they said, well, can you use your APIs, pull this data, put it in this format and this format, and we worked very closely with TUF to define a standard that they thought was great, acceptable for their reporting, and then obviously automating that means a greater level of acceptance when they see the artifacts that they themselves have defined.
Yes, thanks, Neil. So the third theme of those standards is unit or module testing. In the 61508, they call it module testing, and some other standards, they call it unit testing, but basically it refers to kind of the same thing. You're trying to isolate the functionality and test it in isolation to make sure that the API or interface to that fairly tested, make sure that you have structural coverage well covered, and robustness of that individual component is well tested and also tied to a requirement. So there are a lot of facets to this unit and module testing, and through those facets, we also, Parasoft is a provider of a unit testing technology. The product is called Parasoft CC++ test. But throughout, and prior to Parasoft, I was a firmware developer, also focusing on unit testing and unit testing frameworks. So throughout my career, just assemble kind of a frequently asked questions about unit testing. Many people say, hey, what's the value of module or unit testing? Is it just for certification? It's up to you to decide. All of the organizations differ. My take on it is that the value is actually in doing unit tests, because when the developers are starting to perform unit testing in any framework, they realize that they might have forgotten to put some maybe safety checks for invalid input. Maybe they forgot to kind of expose certain data, because now they realize how my module or unit will be used from the outside. Maybe they expose too much. Maybe they realize that the APIs to my little unit should be more restrictive. Maybe I want to refactor it. So there are a lot of value there from just writing unit tests, because your code becomes better. Is the unit testing just to get the coverage there? For some organizations, yes. Some of the organizations, they believe that it's just to get the code coverage, but as I said, there is a lot of value in actually writing unit tests. Can I execute unit tests on host instead of a target? What are the pros and cons? It's a very open-ended question, but the gist of it is yes. I've seen customers, especially in 61508 space, that are getting to SIL 2, and then they are executing all the unit tests with the GCC compiler on a host on Linux, while their actual embedded software is being cross-compiled and tested, hill tested, and system level tested at the actual target. So it's totally, that hybrid is totally possible, and there are pros and cons that I can discuss with you if necessary. What are the most popular testing frameworks and tools? There's a slew of open source tools, such as Google Test, and many people use that. If you want to have certification done at the end, many people prefer to use commercial vendors such as Parasoft. So there's not a shortage of them. Where I look at those is, do you need TV certification? Do you need a qualified tool? Do you need support? Do you need to run on target? And do you need the code coverage integrated into the tool? And do you need the snubbing framework? Those are criteria where I look at, do you need the open source or do you need commercial tool? And do I need TV certified tool? That's a question to ask, preferably at the beginning of the project, not at the end, right?
Right.
A couple words about code coverage. All of the standards, they have some notion of defining what they look for structural code coverage. There are many coverage types here defined. Like one of them is MCDC, which is Modified Condition Decision Coverage type, which is a code coverage type that is normally done for DO 178C customers, for like ASIL level D for automotive, SIL 3 for 61508. So for more stringent level of testing, normally the standards map it to more stringent level of code coverage, and MCDC is the most stringent one. For SIL 2, I believe statement and branch coverage is what the TV auditors expect. Okay. So that's the code coverage. One of the things about the code coverage, I think on this slide, right, while I was talking about code coverage, a technique to get the code coverage could be merging coverage across multiple testing paradigms, such as integration testing, system level testing, and unit testing. So what you can do is you can instrument pieces of your code, let's say file or several files, and run them in your system level bench or integration level bench, and then collect the code coverage, then run your unit tests and merge that coverage together. This way you will avoid gaps in coverage, but you also don't have to, the unit testing as a testing practice doesn't have to carry the entire weight of basically getting you to 100% code coverage. Okay. Requirements traceability. This is Parasoft, and since we play in the highly regulated space, we see that there are a lot of requirements from all of the standards to have a traceability to tests, traceability to design, and traceability to code. So between all of those, right, and all of them are listed somewhere here, there's a slew of testing techniques and tools that help you build that traceability. Parasoft and Lattix, we do have some approaches, but in general, that traceability aspect is extremely important. So Neil, you have more experience with traceability because you're actually a guy in the trenches. We're just a tool vendor. You're a tool vendor and the full-blown consultant for safety. So sure. Why don't you start talking about traceability?
Yeah, can I share my screen?
Oh, yeah.
It's a huge topic, as you say, Andrey, and you know, really from a traceability perspective, functional safety perspective, it's just another kind of dependency analysis. So let me give you an example. If you're doing development to 61508 or ISO 26262, you work with safety concepts, you work with requirements, you work with maybe ASRs, automotive software requirements, stakeholder requirements, you perform HARA, which is hazard analysis, you perform FMEA. And maybe you have a requirements system such as doors or you know, JAMA or something. Yeah, exactly, CodeBeamer. It's very difficult to see which parts of the system are relating in those tools. So what we've done in Lattix is form a product called Tracy, which imports that data from your requirements tool and looks at the relationships between different domains. It's the same as visualizing code dependencies, but obviously looking at instead of code level C++ dependencies, we're looking at domain elements from the requirements system. Where are things verified by, satisfied by, derived from, and where are their gaps? And you can see this particular system, we should have traceability from the safety analysis up to the requirements level. We have that for some things, but not for all items. And you can do that for you know, for any domain. You can see this is the verification domain up to the safety domain and up to the requirements domain. And the idea is I should be able to trace from even the code and test right the way up to the original safety goal. And here you can, yeah.
I have a question, Neil, which bugged me a lot. The DSM as a concept Was it created by Lattix, or is it kind of a generic technique that people can just apply?
So DSM came out of systems analysis of MIT originally. We were the first to apply it to software, and we have the patent for applying DSM to software. And now we've just extended it to the requirements domain and functional safety. And yeah, it's revealing a lot of issues between different domains that people could not see before. It's giving insights. Other thing we can do is produce a multi-dimensional view with the code and the requirements, and show how we can infer dependencies between the code and the architecture. And there you see, have we got any code pieces that are not expressed in the architecture? You can do that too. And you can express must-have rules. So if we say that the architecture must be used or must have a dependency to the software requirements, and that's where you see these violations here, these layering rules. It's exactly the same on the code level. We don't want lib to use subsys. We want lib to be used. We could define layering rules in the same way that communicate that. And then you can also start to put some machine learning and intelligence in that would offer some hints to remove dependencies. So is there an optimal architecture that we can learn and decouple, for example, lib from subsys? So in the same way, you can move between code domains and requirements domains seamlessly and refactor and move things around. So it's a great way of interacting with the data.
It's interesting.
And then finally, if I can show, putting all this together in a DevOps pipeline, we have the ability in a merge request to visualize the architecture data. This is in a GitLab merge request, the difference between a branch and the mainline. And we pull in data from Parasoft, from Lattix together, that enables us to go directly from those cert violations that you were talking about, and the MISRA violations and the AutoZAR violations directly to the line of code, which is incredible, because now we can just do this at the push of a button in a DevOps pipeline.
And I just want to say that this is our next iteration with Zephyr project, just to push the information from Parasoft scanning to GitLab. Oh, sorry, GitHub. Zephyr is in the GitHub. So we have hooks to do similar to what Neil is showing right now. We have plans to do it with Zephyr.
Right. That's amazing. And then the idea is you have a pipeline, a DevOps pipeline that does the testing here, the architecture analysis, and the traceability, and finally produces a consolidated report at the end that's exactly suited for 61508. And that's the final step of the DocOps pipeline. So integrated together.
Awesome.
Yeah.
So that's where Parasoft and Lattix to be work together. Again, shameless plug for the tool vendors. But what Neil and Lattix provide is actually consulting around safety and and CI/CD pipelines in general. So let's go back to the slides, and I think we're wrapping up right now. We don't have much time left. Do you see my slides, Neil? Just check.
I do. Yeah.
All right. Perfect. So we just had a demo, so that's passed. For compliance, Parasoft has static analysis covered really well. We have code coverage and all of the requirements for compliance covered really well, and unit testing and requirements traceability to the units covered under Parasoft offerings. But you've seen that the standards such as 61508 and all of the derived standards, they do talk about architecture. So that's an important piece that many people overlook, but you need to have some sort of an argument to authorities or to your auditors about how did you check that your architecture is sound and solid. So that's where Lattix comes in, and also with their expertise in pipelines and generating those reports on the fly for every pull request. That's why we are partners with Lattix. Okay. As a wrap-up slide, what do you need to do for IEC 61508? You need to worry about, I just listed that, right? Architecture and methods of how you express the dependencies and how you monitor the dependencies to have an argument about data and control coupling. You need to figure out what's your story about coding standards. For example, Zephyr has a very well published and really solid set of coding standards, which mostly include MISRA right now, and then maybe a couple CERT, but I think it's mostly MISRA. So we're working on on getting that more automated and in the hands of people. Code coverage tool is essential, especially when you get to more interesting code coverage metrics such as MCDC, because open source tools do not provide MCDC capabilities. Unit testing frameworks and approaches, we covered a little bit of that, frequent asked questions, and we can have a little discussion if necessary. And architectural analysis, I think that's just an extra bullet there. All right, you can contact, I think, Neil, we've done well under what, 25 minutes and maybe a little bit more.
Yeah, sounds good.
Hope you enjoyed the show and the interactive demo with slides. Neil and I's contact is here on the screen. So with that, thank you very much, and have a great day.
Have a great day, everyone. Thanks for listening.
Thank you.
All right. Hey, thanks very much, both Parasoft and Lattix for the presentation, Andrey Madan and Neil Langmead. Hopefully I haven't butchered your names too much. There are some questions on Discord already being asked in a thread that was created, Q for Parasoft. So if either of you are around and can take a look at the questions being asked there, that would be great. This is on the virtual track Discord channel. But at the same time, we had a schedule for a live stream here, so maybe we can ask the questions directly. So I don't know if that's, are you, see Yuval here? Yuval, I warned, I let people know that we're running a little bit late, so your presentation will begin a bit later. That's okay, hopefully. All right, so just to check, is Andrey and Neil still here? Can you hear us? Okay, why is that?
I can hear you. Yeah, it's Neil here.
Oh, great.
Can you hear me?
Hi, Neil.
Yeah,
yes,
sorry.
very well.
I was on mute.
All right, no
I can
problem.
take any questions here now, if there are any.
Okay, great. So we had one question on the Discord channel. We have, does your unit testing framework conflict with Z-test? That is, would we have to write a new set of tests, or is it compatible with the current Z-test framework in Zephyr?
The Z-test, I think, is based on G-test. Is that correct? Google test?
No, Z-test is its own standalone framework.
Oh, I see. I've not used Z-test myself, so I can't answer that right in this meeting, but I'll check with Andrey.
Okay.
And provide an answer. Maybe I could become aware of who's asking the question, and I could message them directly.
Well, we have there's the Discord channel, so that will remain there forever. So you can always come back to the Discord channel and reply directly on the Discord channel. So
okay, great.
You know, no problem there.
Off the top of my head, I would say the Z-test, if it's C++ based, then we would instrument any tests with that proprietary library using C++ test, and then Parasoft has the ability to instrument third-party test harnesses and produce coverage reports that are then certified. So that would be my initial answer, but I will follow up on Discord with a more exact answer.
Great, thank you. Also, another question is, and actually that one's tied also to the one I was asking. So I usually ask, I would like to know more about how this tool, and by this tool I imagine the one that you've been screen sharing, integrates automatically with Zephyr. And my question is, besides the tool itself, how do you plan to deploy the tooling to GitHub? So what are you planning to run, and at which points in time? Was it going to be on pull request? Because that's going to, I assume that's going to be pretty tough to run on pull request, or is it going to be a nightly type thing?
So we've done both. So on GitHub and GitLab actually, and Bitbucket too, we integrate. So there's a pipeline which is a YAML file. Which is like based on it, Kubernetes in the background or Terraform to orchestrate. And that YAML file then runs with every pull request if desired, so that the software quality results, like the MISRA violations, AutoSAR violations, architectural violations as well, all of that is then displayed in the pull request. And so the reviewer can actually say, well, no, I'm going to reject this merge request or pull request because it hasn't met the quality goals. It can also be automatically configured to automatically reject the pull request and not merge if there's any quality issues at all. So that's already been done, automated pipeline.
Great. So looking forward to that. What about the automatic integration of the Lattix architect tool with Zephyr? I mean, is there any Zephyr specific plugin or something like that, or is it just based on the flexibility of the tool itself that allows it to deal with Zephyr?
Yeah, the tool already works with CMake and the make file system that Zephyr uses. So to build Zephyr it was just a sequence of Linux commands, which were then intercepted by the Lattix wrapper tool. Parasoft uses the same mechanism, the CPP test wrapper, to go around the build commands. We see what commands are built, what files are compiled, what the defines and includes are, and then that is then automatically used to build the model. So that's already been done.
Oh, great. All right, excellent. Thank you, Neil. I don't think we have any questions. There was another question about the tool that was being shown, and Andrey already replied on Discord that this is the Lattix architect tool. And then there's another question actually. In the architectural matrices, is it correct that they were arranged from high level to low level? It was hard to see with the blurriness. Unfortunately, we had the blurriness problem today in the streaming, so.
Yeah, so there's something called partitioning in Lattix, which does the ordering by different algorithms. So that does a usage ordering, tends to put things that are used at the bottom, like your libs, utils, source, OS routines, things that are used rather than using. And it puts the using code at the top, like the application code at the top. So there's automated algorithms that partition the code depending on different algorithms, such as proximity or usage, first in, first out. Those kind of architectural algorithms that can be used to order the system in different ways, provide different visibilities on the architecture.
Great, thank you. And finally, does the analysis tool integrate with tools such as JAMA? I'm not familiar with it, but you probably will be.
Yes, it certainly does. In fact, that's probably our most frequently used requirements tool, together with Lattix and Tracy. Tracy's first module, that's the traceability tool that we showed, was actually with JAMA. So the integration there is probably stronger than it is with any other tool. JAMA has a particularly good API for pulling data out. Might be a little bit slow sometimes, actually, but they're working on that. But it does get everything that we need for that traceability matrix to be generated. And JAMA is a close partner of Lattix and Parasoft as well.
Excellent. All right, I'm afraid we don't have time for more questions. Thank you very much, Neil, for the presentation and for being available to respond to the question. Thank you, Andrey, as well. And we're going to move on now to the next presentation.
You're very welcome. Thank you.